Welcome to another unit in this methodology toolbox. This time I'm going to talk about methods which can be used when you want to test for differences in your data set, like comparing two or more groups within your data set. The classical tests we know for testing differences would be something like the t-test, which usually is conducted as a two-sided test but can be done one-sided as well. Or the U-test, which is also usually done as a two-sided test, or at least can be done as a two-sided test, but can also be done as a one-sided test. Then we also have the F-test and the chi-squared test. Those are like the four classical standard tests to use when you want to test for differences. When to use them? We're going to see this in the next slide. But before we get there, let me tell you a little bit in general, what do you test when you test for differences? And that's actually the difference whether you work with a one-sided or a two-sided test. If we work with a two-sided test, we compare, as the H0 hypothesis, equality with inequality. Income in group 1 is equal to income in group 2, or income in group 1 and group 2 are different. That's two-sided tests. One-sided test means one group is larger than the other. So here we're saying income in group 1 is smaller than income in group 2. And test this hypothesis. That's the main difference regarding how to build H0, H1 hypotheses. Then, we had the four classical tests before. The chi-squared test is actually the test with the least requirements. Meaning, you can also use nominal scaled data and test whether two variables, both nominally scaled, or two groups based on nominal scaled data are actually the same or different. If we increase this a little bit, we get the U-test. The U-test requires ordinal data, and the t-test requires metric data. While the chi-squared test can be used for a lot of different groups, t-test and U-test only compare two groups. If you want to do this with more than two groups, you can use for metric data variance analysis, or for ordinal data, something like the Kruskal-Wallis test. It's like an expansion on comparing simply two groups. Here you can compare more than two groups. This is also a very simplistic approach because this excludes at the moment that we can have paired data. With paired data, this is explained in detail in one of the other sessions, you might have to use a different version. You might have to use not the chi-squared test, but a different alternative here. For the t-test itself, there is an alternative for paired data. For the U-test, there's also something like the sign test as an alternative. And for variance analysis, we also have corresponding alternatives working with paired data. So in this context, if you simply want to describe differences between groups, use one of these methods. If you want to describe test for differences between time 1, time 2, but with the same participants, meaning paired data, then you have to use alternative tests. And that's already done. Everything I wanted to mention in the context of this unit. So I hope you enjoyed it, and see you next time.